So we're Chrysler. We're made up of Lucas, Zachary, myself, Connor, Aasha, Jaydon, and Surya. And for our product, we decided to build a leaf disease detector. So our motivation for choosing this product, we went through so many ideas, from a bird species identifier to a text interpreter. We eventually landed on, we wanted something that would have ample available data and something that would have a real world application. So after tons of iterations and going back over and scrapping this, that, and the other, we finally decided that a plant or a leaf disease detector would be the best thing because it interested all of us and it was applicable.
In order to collect this data, our group used a website called Kaggle. Kaggle had a pre-made data set for us in which we grabbed around 2,250 images of potato leaves, cherry, grape, tomato, and corn leaves. After gathering this data, we uploaded them to another website called Labelbox, which is a vital aspect in training an object detecting AI such as this one.
So using the website Labelbox, we added all the pictures for each label like one at a time. And each category, we split it up like evenly in our group members. So for each category, there was like 200 labels. So that was like 20, 30 labels for each person. And the data from Kaggle had a lot of close-up pictures of single leaves mainly. So using data augmentation, we were able to make our set a little more diverse. And then we wrote a code to sort the images into a training folder, which was about 80% of the data, a validation folder, which was 10%, and a test folder, which was the last 10%. So by getting the remainder of the images, image number after dividing it by 10, we were able to effectively sort all the images.
These are two examples of our images from our data set from Kaggle, and we use Labelbox to train the AI with the 10 categories. We had potato, cherry, grape, tomato, and corn leaves, as well as healthy leaves and diseased leaves, which is shown by the H and the D on the examples below.
So in order to properly train this, we had to use an algorithm from the YOLO's website. We just passed it on through that and used its neural network to train it and classify the different healthy and diseased leaves.
Once we had our trained model, we used the images in our test set to evaluate it. Our model was near 100% accurate for those images, and the results are shown in the confusion matrix. This is likely caused by the fact that both our test set and training set were subsets of our data set we found from Kaggle, meaning that the images in both were very similar.
So we ran into, a fair amount of difficulties during the building and the creation of this product. But with every difficulty that we did encounter, through communication and through every member of the team willing to help out another member, we were able to overcome difficulties relatively quickly and just move forward. And that's something that I really admire about our team.
What lessons did we learn? After finishing our model, we were surprised by its accuracy, and we truly understood how powerful artificial intelligence was. We had our eyes opened at a lot of possibilities, and that our project could change our way of life as well as the world. As with all projects, there's always a scope for improvement, and we could retrain our model with a more diverse data set to improve our results.
So this is the website that we made with the model that we trained. It's pretty simple, but it's effective. I'm gonna upload an image off the internet that was not in our trainings or testing set, because as we said, the testing set was like a subset of the data. This is a healthy, fairly complex grape image. And as you can see, it's hard to see, but you can see in the top left it says grape H if you kind of squint your eyes and figure it out. This is fairly complex. it's the type of image that, if I'm going to show you another one that is also fairly complex, it's a wide shot of a potato. This one it fails to get. I think it's because this is too different from our data set, and our data set was too specific in like close-ups of single leaves. You can see it says tomato healthy instead of potato as it should. This is a limitation that we found afterwards, after we went through a data set and found that, wow, we have almost 100% accuracy. It only missed one, in which it mistake a healthy cherry leaf for a healthy potato leaf. This is the type of thing that I think going forward, you kind of have to get a whole new data set that is more diverse. But it's also important because the application of something like identifying a healthier diseased leaf with an image like this is far more applicable than like close-ups.